start on time. So send a message. It's going to inevitably mean there'll be a few seminars which will have sparse attendance at the beginning and big crowds at the end. And that's just the case of for setting into practice. Welcome to JIAS. My name is John Rapley, and I'd like to, it's good to see you all here, and I'm very happy to see you all again. And just very quickly, JIAS, one of our missions is to sort of, in a sense, reclaim the original mission of the university, the university at large, not the University of Johannesburg alone, but the university itself, to lower the boundaries across disciplines and to allow more interdisciplinary research, more interdisciplinary communication. In some ways, I always say it's modeled, it isn't actually explicitly, but it's very similar to an Oxford or Cambridge college, in that we gather together in this wonderful facility from a variety of disciplines to encourage communication and ideas, sharing of ideas. It's also very much like an Oxford or Cambridge college in that we pay that and feed you well. So now, in addition to which, we try and sort of broach topics that are of tremendous relevance in society today, challenges the society is facing, for which there is a pressing need for answers, and we try and bring intellectuals to bring to bear what their own learning, and so I think Prof. UK is somebody who's very well positioned to do this. She's also someone, I have to say, who's well known to JIAS. She has certainly interdisciplinary interests of her own. She showed up and made a rather valuable intervention at my own presentation on the life cycle of empires, which was a book I was just finishing. So she is someone who I think certainly is able to bring this very interesting perspective to discussion, which, as you know, is very, very salient in the society and also at the University of Johannesburg, which is the role of intelligence and learning in the age of artificial intelligence. So I've asked her to speak for about a half an hour. After that, we will briefly, we won't actually pause, but there will be some refreshments brought in, and you can help yourself, and we will have an informal discussion during which we'll take questions one at a time. So, with no further ado, let me welcome you back to JIAS once again, and we look forward to your presentation.
Thanks. Thanks for coming. It's a nice, intimate group, so I hope we'll have some interesting discussions. This one, I'm not sure how to do. Let's see, where's my presentation? No.
You got it? Okay. It's not projecting.
Okay, so the title, as you have noticed from the notice, it's Intelligence and Learning in the Age of AI. And actually, I left some printout at the corner of the table because this presentation, to some extent, was built from a newspaper article that the VC and I wrote a while ago, a few months ago. But of course, the field has developed and some thinking has developed. So if you're interested, you are more than welcome to have a look at that. And I will also start with, they say the Westerners start their presentation with a joke, and the Eastern people start with the presentation with apology. I don't know why that came from, and you can also think how the Africans put themselves in, but I think I will honor that tradition. I will start with apology. And as you see that it has something related to where I come from. So the apology is that I'm not going to solve any problems with this presentation. I mean, I know sometimes, especially those of us who have been handled through with the PhD, you are not solving problems, you are only understanding. But still, at some time, because I am very interested in to know the impact of whatever we do. I'm thinking of the audience here, thinking of JIAS as the institution that are really interested in knowledge, and the audience here who are probably maybe belong to the people who just can't help to think a little bit more, too much maybe. I think it's probably going to be appropriate still. Okay. So, to further work with your appetite, which is going to come shortly, I'm going to give you a quiz. So, who knows what this is? Who this person or this whatever it is? I can give you a little bit hint. You can see it's a Japanese cartoon, or they also call it a manga. And one of it, you can see that it obviously can fly, and he can also shoot bullets from his butt. actor. And in Chinese, actually called Atom, which is a translation of the name. But what's the, so you guys know the story a little bit, right? What's the story, more or less?
My understanding of it is the father who engineered this boy lost their son and then programmed the conscious of the boy in the robot.
So the boy died due to some unforeseen, some accident. And so the father was an engineer and all the kind of things. So he basically made this boy looking exactly like his boy, but also with conscious, with everything like a boy. And the boy does actually live among the people, and nobody know he is a robot until very late and other things happen and all that. So the reason why I kind of brought this one, I'll start with this, is that this was a cartoon very long ago. I actually grew up. I'm not going to tell you how old I am, but anyway, you can kind of guess. And it's also kind of one of the interesting, one of the cartoons that I watch with my kids, so it's kind of intergenerational. So originally, this was made in 1960s. And the interesting thing that at that time, people were actually quite optimistic. This is happening. I mean, the robot will be living with us. And in the movie, originally was kind of a series of cartoons, is that also there will be lots of those devices that we see now. But at that time, people were already thinking of vacuum cleaner, all the maids, whatever things we don't want to do, they're all done by the robots. So my question is, what happened then? Why it didn't happen soon enough, shortly after the 60s and 70s? And this very famous called hyper cycle by Gardner. I don't know how to pronounce that. But anyway, so they actually every year they will publish their prediction and based on whatever happening in the field, how the different kind of technology evolves and at which stage it is. You don't need to see all the details. So the only idea I want to show you this is that there is perceived of a hype for many of the technology kind of related things. And usually it will shoot up. Maybe that also includes the whole 4IR concept. And then it will dip. And then it sometimes come back a little bit to the stable kind of situation. So what's interesting about this is that during that time, AI actually experienced its first called AI winter, around the 1970s, around that time. And the trigger of that winter is that there was a report coming actually from UK, which basically kind of had a scan of the landscape, what's happening, and to say that our, whatever vision we have is a little bit probably too premature. And then the interest kind of waned and funding withdrew. I mean, not completely, but the whole hype kind of did. But then what's also interesting, and I think more important for me, is what kind of prepared this out of that winter. Okay, I had two winters and 2 springs, so I'm going to talk just now. But this first winter, what prepared it out of it? So in the reading of it, and in my understanding, it's this thing called expert system. An expert system is basically kind of trying to use the idea of getting, to talk to the expert to know in this field what works. So if this happens, what should happen? So based on the expert knowledge, they developed a lot of kind of commercialization usage. And I've kind of listed a few of the fields that that time the expert system was quite popular. So that moved it out of the winter. But then the second winter hit. And this winter came actually quite shortly after the first winter. And some of the triggers I listed here is that people started to again find some tasks are just too complicated. It's kind of hard to define for rules. What kind of rules we need to write down as a code. And some kind of cases are kind of just too much on edge. It's kind of hard to describe. It's very much exceptional, and you can't write a lot of exceptional cases. And then, for example, the vision and speech, how do you program that? How do you define the rules? So I will give you an example. So the question is, what is a chair? So in our mind, I mean, we all have some, if I ask you a question without showing you the slides, you will have some kind of concept of what is a chair. But then look at those pictures. Do they still qualify as a chair? And how do you tell the computer that is a chair? Or that's not a chair? Or even we can even make other kind of example. Let's say if seatability is the definition of a chair, we also sit on the table. So is table a chair? Or between a chair and a stool? So what's the difference? So how do you exactly define that? Telling a computer what is a chair? Okay. So the second AI spring or AI winter, what made the second came out of the second winter is that there were some important enablers. One is obviously the computer power is a lot more advanced during this time, which is a necessity because it wasn't there in the previous one. And the storage ability has increased tremendously. But the other thing is also now there's a lot more data available. Previously it was kind of here and there, but now suddenly people are kind of really starting to store the data and people can access it and you can use the data to train the AI to do whatever things. And one of the important propeller for this AI spring is this concept called deep learning. And deep learning has kind of two main kind of features to it. One is that it uses neural network kind of format, so it's not kind of sequential or kind of linear, but it's based on a network. The other is that it's based on different layers. One layer solves kind of one question, and then it can have a different layer, kind of deeper layer or hidden layer. And I also listed kind of some different types of deep learning that are commonly accepted in the field. So there's supervised learning, and the main kind of characteristic of this supervised learning is that it has a goal. The AI knows what needs to be done, but it also has the training data provided to it. So it will know this is done this right, done that right, not right, and kind of train on it. But there's also more and more the people in the field rely on reinforced learning. Still has a goal, but doesn't have a training data. So kind of the AI just learns on itself. But more interestingly, there's also another type of the deep learning called unsupervised learning, which doesn't even have a goal. So you just feed it with data. It kind of more or less trying to find association, trying to cluster, trying to see patterns. So in this discussion, actually, my interest is to ask two questions. Maybe try to answer it, but not necessarily. But I'm asking two questions. One is that does deep learning specifically resolve the intelligence black box? And the second question is specialization still the way that we should go? So the first question, the intelligence, my English is always kind of at this kind of moment, but anyway. So the black box is actually one of the original aims to develop AI, to kind of really understand what intelligence is, and how to unpack, how to understand human intelligence. In the brain, we know it's in the brain, but what exactly needs to happen for, let's say, our thought to emerge? I mean, we know it's neural, all the neurons were firing, but how does the firing of this one link to the other ones and eventually lead to a thought? So that was one of the aims. So to answer this question, I think we need to ask another question, which is between the issue of performance and process, and I will explain. So AI has been doing very well, especially since the deep learning came into being. And here we are not even talking about the application in the medical field, in the financial sectors, it has been used a lot, or in the manufacturing, that also has been used a lot. Even interestingly, the captcha. I'm not sure how many of you, I mean, we are always asked when we kind of sometimes subscribe to certain things, you need to prove you are human, not a machine. But now, actually, firstly, that thing is becoming more and more difficult. And some people, sometimes you feel that you can't do it and you feel quite stupid about that. But also, interestingly, actually the computers are doing very well at captchas, actually better than humans. Okay. And captchas was one of the early kind of tests trying to really distinguish machine with human, but so we are actually not doing that very well now. And I'm also listing all the intelligence games that people used to think is very human, but now actually AI are beating all of them. Okay. And I'm only going to talk about the last one, which is the stock profit, which is a game. And the interesting thing with this game is that it's not only with all the other kind of games and all that, it also has encrypted information, which is also very hard for humans. But now again, the AIs are doing better than humans. Okay. And now it's going to be a series of interesting slides, which I'm also going to show you the performance AI performance, but I'm focusing on creativity. Because creativity is often thought as something that's very unique to human, very define who we are, that we are creative animals are not whatever, are not. But then see what AIs can do. So the first picture is an AI obviously learned from Van Gogh and learn use a picture and create that. This is also actually there's a that's an AI robot, an artist, and she painted. Okay, and it has been the work has been exhibited now in the Oxford exhibition, and that was I think it was 2018 or 2019. So this one was actually very old. It's in 1956, which is that time there wasn't even AI. It's just computer assisting human to kind of write the music. So it was quite a long. And then look at this. This is 2016. It's the name is called. It's there. Eva, or I don't know how to pronounce that. So the full name is Artificial Intelligence Virtual Artist. So it's the first virtual artist to have her creations registered with an author's rights society. Okay. So AIs are making music. And then this is a poem that an undergrad wrote a program, and then AI wrote the poem, and it was accepted by a Duke literary journal. And the author was like very embarrassed. They didn't tell the journal after quite a while afterwards, and that was 2010. And this was 2019, not too long ago. They decided AI copywriter actually writes better advertisement than human by the number of clicks. Okay, but there's more. So the cooking app or whatever with what's it? And then this is the AI fashion. They create fashion, the design and all that. And AI has also been used to create fragrance. And this is the AI called kind of what's like personal what's that word? No, my head is psychology kind of clinic kind of things to help deal with your well-being. And then this robot, I hope you can't read this. It's 2016 or around that time in Tokyo. The robot wrote the university exam entrance. Didn't exactly qualify, but did a lot better than actually the average human. Almost qualified, and that was quite a while ago actually. This is a movie made with the screenplay wrote by AI. But this one hasn't been too good yet because they say the sentence kind of makes sense in isolation, but when the dialogue puts the actions together, it kind of still reads very odd. So they are not doing too well in that yet. So this is a physicist, and he came up actually in 2013, quite a while ago again. That time he was trying to develop a kind of underlying formula for AI. So eventually he came up with a formula, a physics formula, and then in doing that he creates it's not an AI per se, it's called Entropita. But what's interesting about that kind of program or whatever is that thing can actually take initiative by itself. And it decided to do this and that kind of to make money, which is also funny. You just Google it. And then this, I think some of you have seen it, deepfake. Basically is to use a person, real person, and add on to the facial, add on to the speech that person has never done. And now they can even do videos, not only pictures. And this person, do you guys know who she is? Some of you, it's not a very big picture. Her name is Sophia, and she is?
Google? Is it Google's robot? No.
It doesn't matter where she actually is a Hong Kong company who invented her. But what happened with her? She's the first robot citizen, be granted citizenship in a real country, which is Saudi Arabia. And she has actually been now representing whatever at what UN summit and different other things. So again, Google her.
Does she love to drive?
I'm not sure. I think
She's uncovered, so.
In 2018, they said they gave her a body, so I presume before that, because she was invented in 2016, she was active since 2016. So 2018, they gave her a body, presumably during the time she didn't have a body, but now she has. And she's going to all those whatever summits and UN whatever program or whatever things, which is also interesting. So I would like to compare the machine learning with how actually human learns, because that's one of our original questions. And actually there's a lot of similarities. So in my mind, I'm kind of trying to compare them. And I said that during the first AI sprint, actually when we were using the expert system, we were still using quite of the logic, the rule-based, if this, then that. So that's kind of quite formal learning that we also go through in the schools, often kind of based on rules and grammar and learning all that. But then the second AI sprint, actually any of those three kind of types are more similar to the informal learning, which is not necessarily really based on rules, but based on the feedback. We do something, we get some feedback, and then we know what to change, what to adapt, what to kind of adjust. So it kind of, in a way, both of the learnings also happen in humans. So then back to the question of whether the deep learning actually resolve that black box. Because what has happening is that in the AI field, there's also the movement called explainable AI. For example, in the European Union, they actually have, I think it was 2016 or 17, I can't remember exactly, they actually passed a law called a General Data Protection Regulation, which means that if humans can challenge a decision that is made, let's say, by the AIs, which means that at some point the AI will need to explain how they come up with a certain decision, let's say reject a loan or reject or whatever things. But then the question here is that if the deep learning resembles more of the informal learning, which doesn't necessarily have a very clear rule and all that, how can that happen? Actually, how can we explain? Because if, let's say, we are asked to explain, say, our intuition, how do we explain it? I mean, it's a feeling, it's there, but how do you explain it exactly? And to me, this is also linked to the question of causality versus correlation. Because again, if it's causal, we know what causes what, then it's solvable. But if it's mostly based on correlation, which is what the current AI is mostly based on, it's about linkage between different variables, not necessarily this necessarily cause that. Firstly, there will be lots of kind of factors that link to a certain thing, but then how the relationship between those factors actually lead to the eventually outcome is not entirely clear. So my question is, between this performance and process, can we have it or can we have both? Or we have to choose one? And the kind of the history of AI development seems to be that there's a trade-off. When we are focused on the process, which is kind of happened during the first AI that time was expert, the process is relatively clear, but performance seems to be limited. But then during the second one, the performance jumped. I mean, it was a leap. But then the process seems to be compromised, if compromise is the correct word. So maybe there is a trade-off there. So then my next question kind of move it. I'm asking whether kind of the moving towards the explainable AI is almost the right way to go. Because to me, it's not necessarily we want it to explain, it's the issue of accountability. So let's say AI makes a decision. So the bottom line is that we want, so if especially something bad happens, we want someone to take accountability of it. Someone should be responsible for it. So let's say if an AI, self-driving car, not a person, so who should take responsibility of that? Is it the car company? Is that AI or whoever? How do we hold someone accountable? But that is a completely different question to me. That's a trust issue. There's an accountability issue. And here I will invite you to think of three kind of similar situations. So firstly, expert. So if we meet an expert and they give us some advice, do we always question it? Do we always ask an expert to explain their decisions? I mean, nowadays we're starting to kind of challenge the expert more and more because we do know more and more. But still, there seems to be some kind of trust. I think this, in a way, they have earned their trust. But has AI earned their trust? Because AI, in terms of performance, in terms of the accuracy of their prediction, they are actually doing very well, better than humans. So have they earned our trust? Second, I invite you to consider AI as compared with our children. Because firstly, AI is what we invented, children are what we invented. And secondly, children often kind of outgrow us. So at some point, we also feel that we lose control. It's kind of similar with the AI situation. But in terms of our interaction or our relationship with the children, seems to be that the trust is generally there. Maybe it's because we are similar, maybe because of other reasons. But does that trust, again, exist with AIs? And the last kind of more, I don't know what's the word, to consider wild animals. I mean, not too long ago, I think we heard of the news of game owner, the lion. I mean, he grew those lions up, so it's kind of thought it's partly domesticated and get into the den and basically being, killed by the lion. So is AI more like wild animals that will never be domesticated? So again, I have no answers. I'm just inviting you to think which scenarios would be more likely to be applicable to the AI, or maybe there are other kind of scenarios. Okay, coming to the second question, which is whether specialization is the way we humans should go in, into the future. So basically, the observation seems to be in human. Generally, we start with general, like in the kindergarten, in the crèche, we learn everything, and then we starting to be more and more specialized. I mean, there's always that joke of the PhD is like you know a lot about nothing. And with machines, this seems to be kind of almost the other way around. So even with the whole ICT, I mean, in the early age of it, it's always being separating the task, divide the task, and tackle them individually. So in terms of general machine learning, another one, yes. No, so I'll show you this one. So in terms of the general AI, it's that where that arrow is. So it's very, very early. Okay, so AI in terms of the general intelligence, in terms of the general learning, it's far, far ahead. But the other question is, if we compare AI with human, in terms of specialization, AI actually has a lot of advantage. Okay, they have unlimited working memory. I mean, it's by the computing capacity, but I mean, we human has how much we have a lot more limited working memories. They have lots of training opportunities. They don't need to sleep, unless obviously we plug them off. But the other thing we can't do is that they can play against themselves. And that's actually what prepared this whole fake and anti-fake, because they can always play with themselves, and we human, we can't. It's like we can't startle ourselves, because the moment we do, we know it's coming, and then we can't. We cannot play against ourselves. And then AI doesn't have emotion. I mean, that part is kind of controversial, because sometimes people say that emotion would inhibit, the limitation as a limitation. But sometimes emotions are important when we make a decision and all that. But AI doesn't have emotion, though, so they are at least not biased when we make certain decisions, because that has been an issue sometimes. And also, AI has another advantage, which is that because if they are linked on the internet, they can instantly network it. They can replicate themselves. They can replicate whatever they know from one machine to another. Again, we human can't really do. We have to learn it. So does it mean a better collaboration, coordination? I don't know. So this was, 2017. So the two AI, was it in Facebook? They're starting to kind of, they call it invent a new language, which is basically a language that humans can't understand, and eventually the people got very scared and they shut them off. So, for the AI, we said earlier that the general kind of artificial intelligence is still quite at an early age, but they're actually moving towards that. So, Sophia is possibly an example. I mean, she can do certainly lots of things. She does actually interviews. She does a lot of interviews, like live interviews with humans, and she seems to be doing very well. The other thing is also, I'm not sure how many of you heard of robogamy, which is robot and origami. So the idea there is that you have a kind of standard something, but it can evolve into serve different multifunction. It can be made from one thing to be made into different things, depending on the situation. So AI are kind of not there yet, but they are moving towards that direction. So for humans, takes 10,000 hours to go the rule that we have to learn it that much time to be really good at anything. But then if we need to be good at many things, how many hours do we need? Like this, I don't know whether it's possible. But interestingly, the other concept is that in the age of uncertainty, people having been talking about this notion of, or this tension rather, between efficiency and being robust. So efficiency is good. I mean, we are almost kind of obsessed. The whole system is push us towards efficiency, more efficiency. But efficiency is good when the information is relatively very well defined and there's enough information. And in the world of uncertainty, actually efficiency doesn't really work very well, and at least it's not robust. Because there will be things change, and you can't, if you only know this thing, then you can't really adapt it to a new kind of environment. And actually that's my first time to do that. There's a very interesting TED talk by this woman called Margaret, and she was talking about this tension between efficiency and robust. And if anyone is kind of interested, you can try to see whether that barcode works. I didn't try it because I don't have a barcode reader. And also, Tanner, he pushes this idea even further. He said that being robust is not enough in the situation of uncertainty. What he's trying to kind of push is that, he called it anti-fragile, is that something that would actually gain from that kind of disruption sometimes will be actually doing better in the situation of uncertainties. Okay, that's a fantastic book he wrote. He has a new book after that, but that's a fantastic one as well. Can you try it? Did you try it? Does it work? No. Okay, then I didn't succeed. Okay, I'll try next time. So the implication, I'm asking about the implication with humans. So firstly, of course, we know that there would be more interface between human and machines. I mean, we are not really against them. There will be a lot of things that we need to work with them, and we're already working a lot with them. With, let's say, the phone we have. I mean, now it serves a lot of, I can outsource my memory into a lot of things into them. Or we have a computer, we have lots of other things that we will work together with. But then, my question is still that, do we need to change in terms of our trajectory from being generalized to specialized? And if there is a need to change, especially considering the situation of the world is really complex, and it's really a lot more uncertainties. So if there is a need to change, what would be a good way to change? So previously we've all heard about multidisciplinary team, that's you work with people from other disciplines, which is supposed to kind of bring in different discipline knowledge, and which would be good to come up with a solution. But then the question is that enough? Does one can always rely on another person from another field to kind of coming together? Are we always coming together? Are we talking to one another? So some other kind of proposal that has been on the table is that more and more, actually, some degree becomes multidisciplinary. And one of the examples is that actually our humanity faculty, they're starting to have a degree called politics, economics, and technology. It's kind of just a combination of different things. And also people talking about modular degrees. So you don't necessarily start with a degree, you're heading towards a degree. You're just taking the modules and eventually build up to a degree, depending on what you take, obviously. But the other possibility would be, instead of thinking of the degree altogether, we are not thinking, maybe you shouldn't be thinking of in terms of discipline, but instead of thinking of the tasks, what will be needed to solve a certain problem, and that's what, say, the Finnish school has been doing. I mean, even now in the primary schools and lower level schools, they're starting to teach the kids not based on, say, math and English or whatever. They give them a task, and you need to bring in different kind of skills and thinking different things to solve that task. So it's task-oriented instead of discipline-oriented. Maybe that's a possibility. I don't know. Maybe there are other ways to do it. And that will be the end of the talk. Thank you. And that's my email address.
Thank you. It was a fascinating presentation. I'm sure there's no shortage of questions. I will start by saying, Alan's our colleague who managed to bridge this east-west divide perfectly. Do you start with a joke? Do you start with an apology? He invariably started with a joke. It was invariably bad. Anyhow, so It can't be done. Anyhow, why don't we I'll take a question at a time. So
Also,
that
the food aspect.
the food is now there. So in fact, I'll tell you what. Why don't we take literally 5 minutes? You can help yourself to refreshments. I think you is certainly going to want to fortify yourself, and then we'll begin with the questions right away. All right. So please, the food is here at the level.
Yeah.
Great.
So we need some food, right?
Yes, otherwise our intelligence stops working. The vegetarian.
There's some. So I think we also all need.
Like the phone, you're not worried about it. You don't even find
I'm surprised, like more knowledge of I don't think
you don't even find out. I was surprised, like, I'm thinking I've got sons, I don't have sons.
I thought you went into hiding. I was like,
Come on.
I don't know, maybe below was there.